All right. You get half of the questions from the video from 6th period, the other half of the questions from video from 7th period. I'll try not to, I'll do like one idea, we'll probably do 1, 3, 5, the odd ones, and let them do the even ones. But I will make mention of a couple things because as we go through, there's a few things that I can kind of direct you with. First thing, guys, one of the things that would benefit you greatly is when the problem talks about the distance formula like this one does, if you wrote the distance formula. Just take your pencil, and the question says the distance between A and B, so write the distance formula. So you write D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Now, this is an oversimplification of the concept, but guys, what if you write the distance formula wrong? Do you have any chance of getting the problem right? No, you got to write that part correctly. That's why yesterday before we started, I went over those formulas. I wrote those formulas. I gave you those formulas on that sheet of paper, so that you would have something to go back to make sure you had the formulas written down. From there, guys, it's just substitution. Okay? This says the distance between A and B is 10. So right here for D, you take out the letter D and you plug in what number? 10. Guys, I put a 10 right there because it says the distance equals. So D equals. Okay, now over here it says 3 and 11. Guys, 3 and 11 are my x's. Okay, so if 3 is x1 and 11 is x2, I just come right here and again I just plug them in. Okay, so now I have plus my y1 and my y2. And again, plug them in. This says y1 is just the variable y. So I just come here and I say y minus a negative 4. Well, okay, so now I haven't worked the problem out yet. Look, I've done all of this. It took me a good 2 minutes right there to work through, and I haven't started working the problem yet. All I did was set it up. The thing about this that makes this one difficult is instead of giving you the variables that are underneath the radical sign, you got to find one of those. So if you've got to find one of those, you've got to get rid of that radical sign. To get rid of a radical sign, we talked about this yesterday, if I have x squared and I want to get rid of x squared, I take the square root of both sides, but don't forget to add plus or minus. If I have a square root of something that I want to get rid of, then I square both sides. And the reason I do that is because those two operations are, math term, inverses. Addition is the inverse of subtraction. Multiplication, inverse of the inverse of squaring something is to take the square root of it. So when I square both sides, I end up with 100 equals, well, 3 minus 11 is negative 8. Negative 8 squared is 64 plus y plus 4 squared. All right, some of you, I know this, and this is what I did, guys. When I did this problem on the key, when I made out the key right there, right here, I said 11 minus 3. I had y2 minus y, or x2 minus x1, so I had 11 minus 3 right there. Since I had 11 minus 3 right there, here I had negative 4 minus y. You'll get the same answer. Just in the end, instead of having to multiply a number to the other side, you have to subtract the number to the other side. So when I subtract 64, that gives me 36 equals y plus 4 squared. So just like 5 seconds or 2 minutes ago, I had a square root to get rid of. Now I have a squared to get rid of. When you have a squared and you supply, as a mathematician, you supply the square root. When you supply the square root, you have to work both problems. So x plus 4 is now equal to 6, because that's a number that's squared to give me 36. And y plus 4 is also equal to negative 6. Okay? So then all that's left is just to work and get y equals 2, y equals negative 10. Now, sitting in here, there's some of you that just have somehow or another convinced yourself that that's way too much work for you to do, and you're just not going to do that. Guys, so what y'all did was y'all looked at these, and y'all took these numbers here, and you plugged them in. Guys, if you said let y be 32, 32 minus a negative 4 is 36. 36 squared. That's way up there. 36 squared. Some of you tried to do that, and I thought it was, it was certainly a great idea, because you weren't real comfortable with doing all this work, so you just kind of did trial and error. If you did trial and error and you plug the 32 right there, you still got to do all this. There's no substitute for the work. There isn't. At some point or another, you're going to have to write out the distance formula. Some point or another, in number 2, you're going to have to write out the formula for a circle. That's why yesterday, number 2 or 3, whatever it was on that worksheet, was a circle problem. I made sure somewhere I wrote this. Guys, look, in number 2, when it says the center is at 4 and 3, and you put that number in there over and over again, I've been saying, don't forget when it's in parentheses, you have to take the opposite of it. So I just put a 4 right there. When I put a 4 right there, that leaves me with x minus 4 squared. Coach Hill, you plugged in a negative. No, I didn't plug in a negative. I plugged in a positive 4. Because what it does, since the formula is subtracting by plugging in a positive 4, it makes it minus 4 down here. Plus y minus 3 squared equals r squared. The radius is 2. The r is 2. If the r is 2, then the radius squared is 4. You guys that wrote this, you guys that said 4, 3, you saw a 4, 3 there. You saw a 2, so you wrote 2. That's not a little bitty mistake. You got to keep these formulas correct. In a problem that deals with the Pythagorean theorem, you got to use the Pythagorean theorem. If it's a slope problem, you got to use slope. If it's a midpoint problem, you got to use midpoint. Okay, number 3. Again, find the distance. When you have to find the distance, guys, you can't use the midpoint formula. You can't use just any of those 3 formulas. You have to use the one that's designed to give you the distance. Okay, so 3 minus a negative 1. 3 minus a negative 1 is plus 1. Again, right here in the middle. Guys, if you change that to a minus sign, it's not going to work. It's got to be the distance formula over there. just like it's written. So then you got -8 minus -4. The first step of the distance formula is to substitute. Some of you guys, when you substitute, you want to go ahead and change that to plus, no problem. So what you do is you write 3 plus 1 is 4. So 4 squared plus -4. -8 minus -4 is -8 plus 4 is -4. So it ends up being 16 plus 16. Okay, now, 32. You guys that wrote this, 32. 2 goes into there 16 times. As the whole thing that we've been trying to find is perfect squares. That's the perfect square. The square root of 16 is not the square root of 4. The square root of 16 is 4. If you keep going down and you say 2 goes in there 8 times, 2 goes in there 4 times, 2 goes in there 2 times. As the reason we chose to circle 1 and cross 1 out, circle 1 and cross 1 out, is so that the things that ended up circled go out front. There's your 4 to the square root of 2. In number 5, it's not the 2 endpoints that you have. How do you know it's not the 2 endpoints that you have? How do you know it's not the 2 endpoints? It says, guys, it tells you what it has. It tells you you have one of the midpoint values and one of the endpoint values. What you're finding is the other end. You have this equation, or excuse me, you have these points here. You have one of the endpoints. Find the endpoint A at the midpoint of AB. See, I'm looking for this. I'm looking for this XY. They give you the middle. They tell you what the middle is. So you add these two things together. Well, if you don't know one of those two things, you have to set it up like you do have one of those two things. You have to set it up as 5 equals x plus 8 over 2. Now, look at your work. Again, you guys wrote x1 minus x2, because I know what you did. You got the formulas mixed up. I get that. Because that's the point of what, I know what I'm doing, I don't know what I'm doing, is you keep your formulas separated. I started out and wrote it right here. Write the formula out. Substitute the numbers in. 10 equals x plus 8, x equals 2. Whatever you write as the answer works. So when you were sitting there working it out, guys, and you got 16,243, then you should be able to take 16,243, add it to 8, divide it by 2, and get 5. That's what I'm not getting, is why whatever it is that you write as your answer, when it doesn't work, you don't even find that. You know, if I have -3 here, and I want to add y plus -7 divided by 2, whatever number it is I come up with, whatever it is I think the answer is, when I add -7 to it, it's divided by 2, it's got to give me -3. So it's got to be, my answer's got to be somehow -6. Because what's negative 6 divided by 2? Negative 3. Now, watch where I get the negative 6 from. When I cross multiply here, that gives me negative 6 equals y minus 7. When I have minus 7, I add 7 to get it to the other side. So there's my 1. Again, you guys that got 13 as your answer, I understand what you did. You made a mistake. I'm not expecting you to be perfect, though. Guys, I am expecting you to be conscientious. If you don't care whether or not you're getting them right or wrong, that's not, I can't help you there. Guys, take what you think the answer is, subtract 7 from it, and see, divide it by 2. There isn't but one number in the whole wide world that'll give you negative 3. 1 plus negative 7 is negative 6. Negative 6 divided by 2 is negative 3. When you got 13 minus 7 is positive 6. Positive 6 divided by 2 is positive 3. Okay? The answer works back out to be, and notice that I do that one differently than this one right here. As when you do number 6, this time you do add them together. You do 5 plus 13. You do negative 2 plus 8 because it's half of it. In this problem, they want you to find the midpoint between the school and the stadium. So somewhere you got to write the coordinates for the school. The coordinates for the school is 0, 2. Somewhere you got to look at this and figure out the stadium is at 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So the stadium is at 6, 5. Guys, if I didn't see those points right there, it didn't work. Not good. You got to 0 plus 6. 6 divided by 2 is 3. 2 plus 5 is 7. 7 divided by 2 is 3.5. So if I go to 3, and then I count up 1, 2, 3.5, I can see that the library is closer than the field. Guys, the Pythagorean theorem only works when you put A and B as the legs. These have to be the legs. The Pythagorean theorem only works when C squared is the hypotenuse. In a triangle, how can you look and tell which one's a leg and which one's a hypotenuse? That's always opposite the right angle. That's always the longest side. The reason that's the longest side is because it's opposite the largest angle. In a right triangle, the largest angle has to be the 90-degree angle. The other two, in a right triangle, the 90-degree angle has to be the biggest angle. Because the other two together can only add up to be 90. Because all three of them have to add up to be 180. So if one of them takes up half of that much, the other two can only take up part of that much. 90 of it, half of that much. So anyway, when I write the Pythagorean theorem, x squared is a leg, not the hypotenuse. Again, guys, you can't add 10 plus, several of us added 10 plus 5 and got 15 divided by 15 by 10 got 9.5, and look, x equals 9.5. These aren't arbitrary formulas. They're for very specific things. And I can't use a hammer. I can't use a hammer as a screwdriver, and a screwdriver as a pair of pliers, and a pair of pliers as a blowtorch. I mean, just like in math is the same way. There are very specific tools to do the things that you need to get done. And that's what I'm trying to get you to see, guys. As we move forward, as we progress forward in the next class or whatever, the assumption is going to be that you know how to use, you got this little bag of tools that you know how to use, and you just show up and you open up your bag and you start doing all that now. Okay? And so when you have to find a right triangle, it's going to be x squared plus 5 squared equals 10 squared. So x squared plus 25 equals 100. So x squared is 75. So x is the square root of 75. Okay, by the way, if you've gotten good, I wanted to see if anybody could do this. I wanted to see if anybody could recognize this as a 30, 60, 90 triangle. This is a special triangle. There were two special triangles that we talked about. One of them was a 30, 60, 90, when the shortest leg, look, there's a leg, 5 and 5 on the square root of 3. 5 obviously has to be shorter. If I got 5, by having the number 5, and 5 times some other number, 5 has to be the smallest number. So when the shortest leg is half of the hypotenuse, that's a 30, 60, 90 triangle. Anybody remember the other one? X on the square root of 2? What was that called? Hold on. What was that called? Nobody? X on the square root of 2. Two sides are the same in a triangle. Isosceles, guys. That's an isosceles right triangle. If two sides are the same, it's called an isosceles triangle. And the way an isosceles triangle works is if, you know, one side is, the example that I gave you was 90 on a baseball field. It's 90 feet to first base, 90 feet to second base. First base is a right angle. It's a square. So it's a 90-degree angle right there. So 90 feet from home to second is 90 times the square root of 2. Guys, that happens every time. Every time you have a square, 12 on the square root of 2. 6 on the square root of 2. 5 on the square root of 2. That's what the hypotenuse has to be in an isosceles right triangle. Just like in a 30, 60, 90 triangle, the third side, watch, the square root of 25 times the square root of 3. What's the square root of 25? Is always, it's always the same ratio, guys. A 30, 60, 90 triangle always goes x on the square root of 3 is opposite 60, opposite 30, opposite 60, opposite 90 is 2x.